Okay, so we are trying to find the points closest to the origin for the equation x squared minus z squared minus 1 equals 0. Okay, so this is a hyperboloid, and you know hyperboloid looks like that. Alright, sorry, hyperbolic cylinder. And it'll be like that, and then in this case it's infinite in the y direction, so this would be y. And it's trying to find the point that's closest to the origin, so that could be this point or this point right here, as this is the origin. So to do this, to find the points closest to the origin, you need a constraint, and your constraint would be for x, y, z, just a function of x, y, z, x squared plus y squared plus z squared. Because like this equation, if you minimize it, you can it's centered around the origin, and it would help you find it. It's the distance formula from the origin to any point, right? If you had to do x minus 0 squared plus y minus 0 squared plus z minus 0 squared, just the distance formula, and squaring that, it's just the square root of the distance from the origin and helps you find the distance. So from this equation, we know you can make that into x squared equals z squared plus 1, right? And so this, you're trying to find the closest point to the origin on this value, on this function. We just changed it. And so using this function right here, distance from the origin, you have an x squared value, so you can plug that in. So now f of we were taking out the x value, so f of y z, or we can call this h, equals, so this is our x squared value, so z squared plus 1 plus y squared plus z squared. So that's our new function, and that just equals 2z squared plus y squared plus 1. That's our new h of just yz. We've eliminated the x variable. Okay, so now if you take the derivative with respect to just y and z to find the gradient, so h of y equals 2y, and h of z equals 4z. And then because these are gradients or derivatives, if you set them equal to 0, you can find the critical points. So this gives us that y equals 0 and z also equals 0. So now we know these two, and we had this equation, x squared equals z squared plus 1. So we can also find our x value. We know these two, our point would be x, 0, 0. This is our critical point. We need to find what x value now. So we know z is 0, so 0 squared plus 1 x squared. So x equals plus minus 1. So now we have the points 1, 0, 0, negative 1, 0, 0. And so from our drawing earlier, we know that these 2 points would be closest to the origin of this function. So like this could be something like 1, 0, 0. This would be negative 1, 0, 0. Just on a 2D drawing. Yeah.